My next example is a really interesting picture. O is the center. All right. Of the circle, okay, there's only one circle there, so that's fine. O is the center. What does the center give me? So I'm thinking about those 4 theorems that all have centers in them. So look at your cheat sheet, and I'm seeing radius, which gives me S1 will be the same as T1, right? Got tangents, have I? Are those tangents? Let me double check. PQ, QR, and PR are tangents. Okay, they are tangents. So I've got tan red. So I'm going to do these in a different color. Got two of them. Just want to cover the T1 and T2 and then the S1 and S2. Right. Anything else from the center? Angle at center is angle at circumference. Nah, there's actually no angles made at the circumference by a chord. Isn't that interesting? Okay, so I dealt with the center and then I dealt with these tangents. I'm just seeing now that obviously there's tangents from the same point. So I must just be mindful of the fact then that T2, let's call T2 a dot, is the same as S2 because these guys are the same. Then I think I've covered the center. I think I've covered these tangents. I've got to prove PSOT is a cyclic quad. Right, so that thing I've put in yellow now. So cyclic quad, we've got a whole bunch of angles in the same segment. I can see them there. I don't have any of them equal to each other though. Exterior angle equals interior opposite. I do have, look, angle T, this one here, this is a right angle, and then equals interior opposite. It's not labeled, which is kind of a way of telling me to maybe find another way of doing it, although that would be perfectly fine. If I wanted to label that T3, I can go ahead. I think the easiest way is to just go opposite angles of a cyclic quad. Okay, so this one was really straightforward. And it's got to do with the fact that I'm given all this information from the tangents, but I need to lay that out. So it's all really obviously in front of my face now, but remember I got there from the information that was given. That stuff wasn't on the diagram to begin with. Okay, so T1, this is question A, T1 plus T2. Those guys equal 90 degrees. My reason is tan red. Okay, then on the other side, I've got the same story. I've got S1 plus S2 is 90 degrees, also tan red. I'm doing the reasons in brackets because I'm not working side by side. And then, therefore, PSOT is a cyclic quad. And my reason is converse opposite angles of a cyclic quad. I'm going to add in here 90 plus 90 equals 180, just to be really, really clear. So now what can I add because I've got the cyclic quad, because I'm expecting scaffolding questions. So now I've got this lovely cyclic quad. Okay, so now all of these alternate angles, so now all of these angles in the same segment are going to be equal. So this one that I had as a single bar that was the same as that one, I have more of them. I also have that one being an angle in the same segment with S1, and then this one is an angle in the same segment with P2 over here. So those guys are equal. And then O2 is going to be the dot that I had there. And S2 is also a dot from the two tangents from the same point. And then my other dot that goes with S2 will be O1. Not all of that's going to be used now, but it's really useful to go and add stuff as soon as you know that you've proved something. I've just cleared the screen to make it easier to see, and I've drawn a really, really bad circle SPE. Okay, so OS is a tangent to circle SPE. Prove that. OS. OS is a tangent. Okay, can we just make that an actual tangent looking thing? What would you have to be able to prove to know that that's a tangent? I think we're looking at tan chord here. Okay, which means S1, so the one made with the chord, would need to equal the one made from the chord or by the chord. S1 equals P2. I've got that. I've actually got it. Now I need to lay it out. Okay, so again, I'm actually required to prove that S1 equals P2, right? So let's see what is S1 equal to, and then what is P2 equal to, and they're going to end up being equal to the same thing. S1 equals T1, and the reason there was angles opposite equal radii. Okay, and then what else is T1 equal to, or what else is P2 equal to? Well, it turns out each other because of the cyclic quad, so I'm going to go there. T1 equals P2, and it is angles in the same segment. And I'm just going to be really pedantic, and I'm going to put there the circle that we have proven, because when you've proven a cyclic quad, you've proven a circle. Okay, that's my reason, right? Therefore, S1 equals P2, which is what I wanted, right? Therefore, you've got OS is a tangent to, what was it, circle SPE, and my reason is converse tan chord. In this last example, I'm told that these points are concyclic, so A and D and C and B and P are concyclic. You know what I want to do there is I want to check for cyclic quads. Okay, so you see that ADCP is cyclic and ACBP. So I'm seeing A2 and C2. Those are going to be angles in the same segment. Are there more? Yep, we've got P2. Sorry, it's not P2, it's P and B. Those will be the same. And we have more information. We're told PC bisects, there's that word again, D, C, B. So we are told that that line PC makes angle C cut in half. So if I've labeled C2 a single bar, I need to label C1 a single bar as well. Okay. What I'm supposed to do now is I'm supposed to prove that PA bisects XAB. So I'm actually required to prove which angles are now in XAB. Do you see them? I'm supposed to prove that A1 equals A2. Well, I've got something with A2 going there that I got from angles in the same segment and then the information they gave me, but I've got nothing with A1. But remember I talked about cyclic quad? Look at the cyclic quad ADCP. Well, A1 equals C1, right? Because it's exterior angle. So actually, I have proven it, and now the challenge is to lay it out. Right, first step, let's go with what we're given. C1 is C2, right? That was given by the things being bisected. And then let's go with what C1 was also equal to. So C1 also equaled A1. And that was exterior angle of a cyclic quad. Okay, and then what more? What more is we had that A2 equaled C2. And how did we get that? It was angles in the same segment. Okay, then we need to go a little bit further, and what we need to also put down is that we've got A1 and A2 are now equal to each other because of other things being equal. So if we've got C1 is C2, we've got C2 is A2, C1 is also A1, so therefore they're all equal to each other. So therefore I've got A1 equals A2. And you see that angle B and P didn't come into the picture here, but I think it was still useful. All right, so therefore PA bisects angle XAB.